In our instructional video today, or our set of instructional videos today, we're going to be working with a more sedimentary type deposit. So it's fairly simple deposit in some ways, and it's really to demonstrate all the capabilities and all the general workflows that you would be using and things you might run into, and just to get a basic idea of how the workflows in the software work and how powerful they can be before you progress into more complicated data sets. So this is the Dunker Road data set from Duluth, for those who are familiar with it. And as you can see, we've got very simple geology here on this side. We're not going to be focusing on that side much, but here we just have these sort of sedimentary layers that we're going to be modeling. So I've already set it up to have a model boundary, model extend here, so I'm not going to go through that here now. And it's all nicely aligned with the majority of the data. Alright, let's get started. Alright, so the first step is generally to create a topography already. Although it's fairly flat, I'll just go through the process. So what we can do, we'll take the color points, actually create topography, and for this we actually go to the surface-based modeling. Different ways we could do it to turn these color points into a surface that we can use for the volumetric modeling. But today I'll just use the implicit surface from points here. So we connect that by dragging from the color points to the implicit surface. And the implicit surface, you just click on it and drag there if you want to, or click and click. So now we double click on the implicit surface from points here. So by default we have some settings where it specifies that we have unorganized points, which in this case we have. Alternatively, in this case you could say that it's actually topo data, which assumes that the everything above it is air, sort of. So it helps in orienting the points. Other options would be unorganized points if you have very steep hills and things in your data set, very steep inclines, declines, then you'd probably use that one. If you have points oriented at a different angle, you can try to use a best fit plane, but today we'll just use the topo data. So most of this can actually be ignored by using this selection. Relative range, we'll leave it as it is. So the level of detail is something you can play with. We'll probably want to have quite a high level of detail, so set it up to 10. We'll give it a name, topo surf, and just to demonstrate something. So with our model bounds, we've made this one the active model bound, so our surface will be clipped by this later on. So let's go back to the processing. We'll run the process. Shouldn't take too long. We've got something that's sort of representing the topography quite nicely. Alright, so yeah, we'll use that later. For now I'll just leave it as it is and I'll turn that off. We'll clean this up. Alright, so now we go back to our data and we'll start modeling. So I think at the top here, if we click on this is already unit 7, and there's some other parts up here. It's also unit 7, so that starts nearly at the top, and here unit 6 is below that one, and yeah, that's roughly the order in which we need to do our modeling. So typically you would start from the youngest unit, in this case unit 7, unit 6, all the way down to the oldest unit. So for this we'll start with our actual drill data. So we have the color that traces in the actual data. I'm using the actual data here, and then go to volumetric modeling. And what we do is we convert the intervals that we have into volume points. Some of you might be familiar with this technique, typically being used for more intrusive style type deposits or units or domains. But in this case, we're actually using that as well for sedimentary type layers. So at the top we have the attribute, so the data column on your drill data, and then you can select which category you want to model. So we have a number of categories here. I haven't cleaned this up, and I'll show you in another video how you could do that. So at the moment we just say, okay, we want to have unit 7, which is the topmost unit, and we want to create volume points for unit 7 only compared to everything else, because it's the first one. We don't want to ignore anything else, and I'll go into that in a minute and show you what the effect is of that. Down the bottom here we can sample the drill hole traces to create these indicator volume points. At the moment I'll just leave them at the default, so this would create an indicator point every 5 meters. And for the inside unit, so for unit 7, for everything else it's also set to 5 meters intervals. I'll leave that as it is. Also these values, just leave them at the defaults. I'll press OK, and I'll start running it just to show what happens here. So as you can see, we've converted all the areas where we had all the intervals where we had unit 7 as a label, and turned those into positive points. So you can see that when we zoom out that they're red, and everything else is blue. So there's nothing above unit 7, at least not in our modeling area. So what this does is it's converting all of space and saying, oh, everywhere where we see blue, that's considered outside, and everything where is red is inside. So this volume is defined by all the red points that we have. We'll be repeating this process for the other units, but for now we'll just focus on unit 7. So from our quick analysis, there was nothing above the unit 7 here, so we don't have to model anything except the topography, which we already did. But now we get into the more typical workflow for how you would do any modeling. So for this unit 7, we converted it into indicator points, and then we can use a classification. So here we're using machine learning to classify the inside and outside of these points. So we're constructing what we call machine learning function, which defines where in space the inside is and where the outside is. So I'll say this is unit 7 function. So this is indicator, so we have different types of fitting, but typically the exponential is fine. So the most important parameter is actually this range setting here. So if we look at this, we might have to play with it a little bit, but in general it could be almost half the interval width between drill traces. So here I'll leave it at the default. I could have increased it a little bit maybe, but I'll try the defaults first for this one. So yeah, we have the range setting. We'll leave everything else at the default, which is fine. And now press play. So now what we'll see is that we get these functions. So I'll go here on the functions. It's created a function from these intervals. What you can see is that it's actually creating blobs here, which is not really what we want, is it? So let's take a slightly higher resolution for these ones, so you can see a little bit better what they're doing. So maybe we have to start looking a little bit closer at our drilled faces. Let me see what's going up here. So yeah, notice how there's these little sections up here with overburden, which we didn't model. So this one turns the intervals not so much in an indicator layer as we sort of wanted it. It's turning them into blobs. So what we should actually do is first model this tiny layer of the overburden. So what I'll do now is I'll go back to this one, but instead of having this, we'll actually go and do the overburden. So now it automatically changes the name to overburden indicator. Leave everything at the defaults. So automatically change the name here as well, and then run this one. So this is gonna create another function now for the overburden. Look, this is a lot better. This is what we want. So yeah, this is the first unit, which is just modeling the overburden. It doesn't seem to honor the data very nicely, and that's partly due to the accuracy here. It's also something that we can play with in the settings. I'll leave that for a separate session where I really go into depth and how to improve the settings so it will honor the data more closely. For now, I just want to focus on the general workflow, and then we'll go into these details later. Alright, so now we've done the overburden, which was actually on top of the unit 7. So what we're going to do now is go back to unit 7, but this time we have to ignore the overburden. So we've created a function for the overburden already, so we've defined this inside-outside space for the overburden, which is on top of the unit 7. And since that's already been modeled, we ignore it in this step. And I'll show you what happens if we do that. So we leave everything at the default as we've done before. Run this one. And so now we had our original unit 7 function here, so let's turn that one off, and the overburden. So now we get a function that's actually fairly flat. So this is more like a sedimentary type boundary, if you want to call it that. As you can see, ignoring the overburden completely removes this this blob type function that we got originally, and that's because there were in the previous attempt some additional outside points above the unit 7 here. So the function tried to close in on itself to also exclude the overburden. And by ignoring the overburden, it didn't need to exclude those anymore, and you get a really nice continuous boundary between unit 7 and everything else below it. So the next step for the next layer, which would be unit 6, we'll do something similar. But let me warn you, there's something in here which is called oui. I don't know how to pronounce it, or oui. It almost sounds like French, oui. And I'll not ignore this one. So you'll probably notice something similar going on here in this region for you modeling the unit 6 as we had in the initial modeling of unit 7. Alright, so let's go back to our processing. So now we'll leave this workflow as it is. We go into this one and we go to unit 6. So since we've modeled unit 7 and and the overburden already, we actually need to ignore those ones in this processing. Remember that we tried to model layers in this case, so everything above it should have been modeled already. So the overburden and unit 7 have been modeled, so they don't need to be excluded anymore, otherwise you get these blobs again for that one. So we want to ignore unit 7 and we want to ignore the overburden, and we'll leave everything at the defaults for that. And just rerun this one for the next function. So here it seems to be okay, I think. So if we take a finer one, you start to see a bit of an artifact here, and that's because this other unit, or this single label up here, is saying that actually this needs to be excluded from the unit 6 volume, and in this case we don't want that. We actually want to have this as a boundary between unit 6 and everything below it. So we need to also ignore this one. So remember that. If we go in here, we have this we, and just to make sure I'll do both. I was not sure, quite sure which one it was. So we'll ignore it both and rerun this again. Yeah, so now you get a better model, and you see that this is not producing any artifacts here anymore, and this is becoming more continuous over here. So this workflow was going to continue for the other layers, so let's go back to the workflow. We shift to unit 5. So remember, we need to ignore these ones that we've already modeled, or that we really want to ignore anyway. So that's the overburden, unit 7, unit 6, we've done all that. So this we needs to be ignored as well. And again, leave everything at the default so we can see what it looks like. So we go back to our sources. Yeah, this is a bit of artifact here, so we need to turn these off. So this is the unit 7 curling around a little bit. So we could have probably set up a higher range, and it wouldn't curl up so much, but this is outside the model area anyway, so we don't bother too much with that. Also notice that for these functions that we're creating, these are represented as sort of like a surface here, but they're actually volume renderings. So there's a different technique for displaying them. So we're actually using ray tracing techniques, which can't really cope with oriented bounding boxes. So they're really just a preview, as we call them, of the actual function. So the function actually continues outside of the bounding box. It continues everywhere, but it sort of takes the same sort of size as the model bounds that we're using. This is not so much of a problem. It's just a bit of a visual awareness. Let's say that, and we might try to improve it a little bit so it would actually cover more of the space. But when we actually get to the actual modeling, where we actually create our complete models, then we'll also only calculate them within the model boundary here, where we're not using ray tracing anymore, but actually calculating the real end models. But now we'll move on to the next one. So we turn this one off already, and we just go to processing. So we just keep going down the stack. So remember every time to disable all the ones that we've already done. So overburden, unit 7, unit 5, unit 6. There we go. If you have something like this where it's not quite sure, and probably could have done that for unit 5 as well when we're modeling, but you probably want to ignore this one as well. There might be unit 8. I think there's only one trace where it's been labeled. It doesn't interfere with what we're doing at the moment. But yeah, so everything that's sort of like an anomaly, it's better to ignore them here if you're not quite sure. So really only include the models where you know that you want to have a distinction between the unit that you're modeling and everything else. Alright, so we move on to unit 4, calculate that one. Yeah, that still looks quite fine. Just go back to that one. Go to the next unit. So we now do unit 3. Same process, disabling all these ones. Might as well. Let's do that one. And then we have these ones here. And press OK. So you get the picture here. And now you start to see that there's some other things turning up here. So this is where we'll stop with the modeling here. We need to start looking at other units as well that are not labeled just unit 127. So we'll just leave this as it is for now, and then we start building the models. Cool. So we have all the functions that we've created. We have a topography surface that we've created. We have the overburden function, and we want to turn this into a model. So the thing that we need to do is actually turn this topography into a function as well that we can use, because otherwise it can't be used directly for the final modeling process that we're demonstrating in the next video. So what we need to do is we need to take this topo surface and turn that into a function. So what we do for that is we take something that's called the sine distance function. It's roughly similar to what machine learning actually does, where it takes the inside and outside points. But here we actually take the surface itself and use that to say this is the inside, this is the outside. So we can actually look at that by coloring it by the positive and the negative, or the indicator value. So we have positive at the top above the topography and then blue, negative below it. So if we go to a processing, we can turn this into a topo function, and we'll see that that's now representing, you see it's sticking out there as well. There's the volumetric rendering that we're doing here, and you can see that it's in place of this topography surface quite nicely. Now we actually go to create that, turn that into an actual model. So the actual modeling takes place by creating what we call model descriptors. So a model descriptor, and I'll create one now, demo M1. It's sort of a description of the relationship between the different domains. So it's really a domain-based modeling where you take every domain and specify an order and of importance, and an output label associated with that domain. So typically we have a function that we want to use. In this case we want to start with the topography, and everything above the topography, we checked that everything above it was positive, so everything above it should be removed, and in this case we just label it as air. I'll just demonstrate what it does, so I'm not going to add anything else yet. We're just going to press play. This brings up a dialog with a base resolution. Okay, that's all fine. Let's start processing. And while this is starting to process, I'll pause the video so you can see that it's actually working in the background. So I'll pause the video until it's done and then return here. So now this is done processing, so we go back to 3D. I'll turn these things off and show the data. So now you can see that the model is actually nicely sitting within the model bounds that we've defined, with two layers at the moment. So we have something labeled unknown at the bottom and something labeled air at the top. So you can see the topography looks like it's using the surface, but it's using the actual distance function that we've created before to actually make this separation between everything below it and everything above it. So everything above topography, we just label it air and doesn't play a part in the further modeling. So everything labeled unknown is like an unknown label to any domains. So what we're going to do in the next step, next steps actually, is to build up the model by relabeling, by cutting the unknown side into separate domains. So we go back to our descriptor, we start to add functions to it. So here we take function 7, leave everything at the default, so everything on the positive side for function 7 is going to be labeled 7. I'll just do it for 2 functions at the moment. So again, we start from the youngest to the oldest typically, and this one is going to be labeled unit 6, so just a 6. So what we have now is a bit of a description of how we're going to build our model. So the first function that we're going to use, so the function is listed here, is the topography function, which separates everything into unknown. There's no outside label, but it's basically going to produce an unknown because it doesn't actually apply anything outside. And everything that's inside this function that we've created, so above this topography surface that we've created, is labeled air. And similarly for the unit 7 function that we've created, everything above it is going to be labeled 7. Everything above unit 6 function is going to be labeled 6. Alright, so does that not conflict with what we've done before? Well, this is where the logic in the software comes in. So because everything above the topography is already labeled in the first step as being air, it's not going to be affected by the second step. So everything that's already been labeled air is discarded for further processing, and only the unknown region, so everything that's only visible here, so it's going to be used to be labeled or partially labeled 7. Similarly, after we've processed unit 7, there's going to be a bit of a leftover unknown area. Again, I do the same thing. So that the unknown area is then going to be used to label unit 6. So I'll demonstrate that by running this one again. Alright, this is now going to start processing again, and when it's done I'll return here, so I'll pause it for now. Okay, the process is now done. I'll go back to the 3D view. I'll show the data there. So we have a new model. And as you can see, we still have we still have the air sitting on top. Down below that we have unit 7, unit 6, and remaining area of it's still labeled unknown because we haven't further modeled it. So if we go back to these functions, so this is the unit 6 here, and compare that to the data that we have, we see that this function is actually cutting through this model. So the unit 6 sits on top of this function that we've created, and it separates everything below it with everything above it. But since unit 7 was processed before that, it was already labeled, or it was already modeled as a single domain here, and similarly everything above the topography was labeled air. So also notice that I didn't actually model the overburden as such. I could have put that in here as well, just have a small layer of overburden. But since I didn't do it, everything between the topography and the function for unit 7 is now labeled 7. If I wanted to include the overburden, I just have to put in the overburden before I do unit 7 and unit 6. But yeah, let's just continue, and we can build up a complete model description this way. So we'll add function 5 now, leave everything at the defaults, and then same for function 4. So this way we can easily just set up the description of how we build our model. Or no, this needs to be level 3. Alright, so the last function that we created was unit 3. So this one is a bit of a special one. So if we want to continue modeling, we could create unit 2, unit 1, and so on until we've modeled everything. But if we want to have everything below unit 3 and say, oh, we're not interested in that, we can give that a separate label. So instead of just leaving it unknown, which we might do, we could also say, oh, this is actually unit 2. We could take one of these ones, or we could just say this is the base of the model. So that now has an output called base. So we've set up a complete description now of the model that we want to build. Of course, I didn't need to do all these intermediate steps for it, just creating a model with air and just unit 7. So I could have skipped these two, but it just serves to demonstrate what it actually does. So now we can build a complete model and just doing the same thing, pressing the play button, select OK, and then it will start sampling and updating the complete model and start building it. And I'll start pausing the video now until it's done. So now the model is ready. You can have a look what it looks like. Let me just turn that off. It's on. Okay, let's look at the different layers here we have. So as you can see at the top you have the air, and as you can see that it's actually covering all of the topography, so we can remove that just turning it off. Took a bit of time now. Be a bit more patient because it's a full model with lots of tetrahedra. We can actually see what it looks like with turning that on the tetrahedralization or the triangulation, as it were. If you wanted to look at it that way, you can see how it adapts to the actual functions and where they've been modeled. So you can actually see finer resolution near the boundaries, and away from that it just produces really coarse, which is exactly what we want. So we have a number of layers in this model. So at the bottom we have the base layer now, so that's everything that we haven't really actively modeled. We could extend that, and then from the top we have unit 7, unit 6, and so on. Yeah, this is the result of a relatively simple, straightforward model that we've built. Now we can start looking at improving some of the things that we've done and saying, okay, let's improve the functions and things that we didn't quite like so far. Alright, I'll do that in the next video. Thank you. Good luck.